All right, greetings everyone. Welcome to the second part of the video on section 6.3. We'll continue on with our studies of the inverse functions of sine, cosine, and tangent primarily. And now we'll look at how we can use the information we found in the first video to help us do some problems. So let's look at these. So here we're asked to use our knowledge of inverse functions as well as the unit circle to find the values of each of the following, and we're asked to give our answers in both radians and degrees. And a couple of things I want to note first about inverse function or inverse trig functions that we talked about in the last video. So just a reminder that with inverse trig functions, we're inputting ratios and outputting angles or angle measures. Okay, so all of these things we see here that are input into our inverse functions, those are all ratios. So our answers should all be angle measures. The other thing we need to keep in mind as we do these problems are the range of each of these functions, which is something we looked at in the first part of this, in the first video for this section. So recall that the range for inverse sine was negative pi over 2 to pi over 2. So any outputs that we get from these inverse sine functions here need to be within that range. For inverse cosine, this is one of the ones you were to look up yourself. Well, in that case, our range is a little bit different. Its values between 0 and pi. Okay, so any outputs we get from these inverse cosine functions here need to be in that range. An additional thing we can think about along with these is the quadrants that these answers are in. Okay, so for the range for inverse sine, we have negative pi over 2 to pi over 2. Well, if you think about the unit circle, draw that up here, a coordinate axis, we know that pi over 2 is here on the top part of the vertical axis. I should say positive pi over 2. And negative pi over 2, well, that's actually the same as 3 pi over 2. So we're talking about here. So for answers we're getting for inverse sine, they need to be in this area, which would be the first or the fourth quadrant. For inverse cosine, we're looking at a range of values from 0 to pi. And we know 0 is here along the positive part of the horizontal axis, pi is over here. And so if we're looking at values between 0 and pi, we're looking at here. So we're looking at quadrants 1 and 2. Okay, so I'm going to keep that in mind. So inverse sine gives us values in quadrants 1 and 4. Inverse cosine is going to give us answers in quadrants 1 and 2. Okay, let's finally now get to answering these questions then. So if we look at finding the inverse sine of root 3 over 2. So recall that what is inside of the function there, that root 3 over 2, that's a ratio. And it's a ratio that we know appears on the unit circle. So we need to think on our unit circle, where does the sine of an angle equal positive root 3 over 2? And we know there are two possibilities, right? We could have an angle here in the first quadrant, also an angle in the second quadrant. That's where sine is positive. However, again, remembering our range for inverse sine, we can only have answers in the first or fourth quadrant. So we know that the answer we're looking for is going to be this one right here, where inverse sine is, or sorry, where the sine value is equal to root 3 over 2. And the answer for that would be at pi over 3, which is the same as 60 degrees. Okay, so inverse sine of root 3 over 2 will give us pi over 3. All right, inverse sine then of -1/2. Well, again, thinking about our quadrants in the unit circle, we know that sine is negative in both the third and the fourth quadrant. But again, we know that, excuse me, answers from inverse sine only come from the fourth quadrant. So we're looking at this angle here. And if we think on the unit circle, where sine is equal to -1/2, well, that's going to be at 11 pi over 6, or 300 degrees. Sorry, 330 degrees. I knew that was wrong. Okay. However, again, recall that our range for inverse sine is negative pi over 2 to pi over 2, or negative 90 degrees to positive 90 degrees. Well, 11 pi over 6 or 330 degrees does not fall into that range. So what are we going to do instead? Well, we need to find a coterminal angle with these two angles, or with this angle, that is in that correct range, which means we need to go back a rotation, because if we do that, we'll end up at negative angles. And if we do that, I believe we'll end up with an angle of negative pi over 6, or negative 30 degrees. Because if you look at the picture here, if we rotate backwards, pi over 6 radians, or negative 30 degrees, sorry, negative pi over 6 radians, we end up at that same spot. So that would be our answer there. So again, we have to pay attention to our range on inverse sine, and inverse cosine for that matter. Okay, let's look at the next one. So here we're asked to find inverse cosine of root 2 over 2. And so we again have to think where cosine is positive. Well, that'll be in the first or the fourth quadrant. But as we saw down here, inverse cosine only gives us answers in the first or the second. So we know we're talking about the angle in the first quadrant, where cosine is equal to root 2 over 2. And we know that the answer for that would be pi over 4, or 45 degrees. And then for inverse cosine of -1/2, we are looking again where cosine is equal to a negative number, which is either going to be in the second or the third quadrant. Again, inverse cosine only gives us answers in the first or the second, so we know we have to give the answer from the second quadrant there. So if we think about where is cosine equal to -1/2 in the second quadrant, that would be 2 pi over 3, or 150, sorry, not 150, 120 degrees. Okay, so that's evaluating these using the unit circle. All right, let's look next then at evaluating these if we have values that are not on the unit circle. So here we're asked to find inverse sine of 0.97, inverse cosine of 0.4, and inverse tangent of -1. And here we're going to focus more on finding the answers for these in radians. I know that the directions say to do it in both degrees and radians, but we're just going to focus on the radians for right now. And I again want to reiterate that when we find answers using inverse trig functions, the inputs are ratios and the outputs are angle measures. So we want to keep that in mind as we do this. I should also point out that we're going to do this on the calculator, because notice 0.97 and 0.4, for example, are not sine or cosine values that fall in the unit circle. We'll talk about inverse tangent when we get to that one. All right, so let me share. So we can use our calculator to do this. First things first, we need to check the mode we're in. So I'm going to hit mode, and remember to look on that fourth line down. Make sure that you have the radians button highlighted, which I do. So that's what I want. So then I can go back to my main screen. Okay, and then we're going to do the inverse sine of 0.97. So to do that, I hit the second button, and then you'll notice right above sine, you should see an inverse sine button. So we'll hit that. It gives us the inverse sine. We'll put in that ratio, which is 0.97. Press enter, and there we get the angle where the sine ratio is equal to 0.97. And again, I'm going to continue to iterate because now these are all decimal looking things. This right here is a ratio. And this 1.32523, even though it looks just like a number or perhaps a ratio, that is our angle in this case. And recall that we did this in radians, so it's a radian measure. Let's also think about what quadrant this is in. Because the sine value was positive, so the ratio that we put in was positive 0.97. Well, we know sine is positive in both the first and the second quadrant. But inverse sine only gives us answers in the first quadrant, so we know this angle 1.32523 is in the first quadrant. Okay. All right, so let's do the next one. So we'll do inverse cosine of 0.4. And that gives us 1.159. And again, just to reiterate, that 0.4 is the ratio. The 1.159, that is our angle. And we'll again think about where this would lie on the unit circle. So cosine, we had the ratio we have here is positive again. So we know we're working in the first or the fourth quadrant, but inverse cosine only gives us answers in the first or the second quadrant. So we know this angle of 1.159 is going to be in the first quadrant. All right. Let's now do the tangent one. So we'll do second tangent. And the ratio we had was -1. And in this case, it gives us negative 0.785398. Okay, so we got a negative answer here. And let's think about why that is. So again, remember that negative 0.785398, that's an angle measure in radians. If we think about what we input into the inverse tangent function, well, we know it was negative, and we know the ratio for tangent is going to be negative in both the second and the fourth quadrant. And the reason we know that is because tangent is sine over cosine. And if the tangent comes out to be negative, that means the sine and the cosine have different signs. So we know that we have to be working in one of those two. And then we know inverse tangent. We didn't talk about this earlier, but you hopefully found that inverse tangent also only gives you answers in the first or the fourth quadrant. So we know this answer here is in the fourth quadrant. Also recall that the output values for inverse tangent go between -π/2 and π/2. So the angle we're getting in the fourth quadrant should actually be a negative angle, which is what we got here. Okay. All right, that's it for now. Thank you for watching.